Okay, so now we are going to see how to continue solving nonlinear inequalities. Okay, so this is our next example. And so we've got an inequality that says x is less than or equal than 3 minus 6 divided by x plus 2. Okay. Now, under other circumstances where this might be an equation, right? Not an inequality, we might think that we can just multiply on each side by the denominator and start solving it that way. We cannot do that or use that procedure with inequalities. Why? Because remember that when we multiply or divide by any given number, if that number is negative, then the sign, the symbol of the inequality has to flip, okay? And so that is important to take into account, because if I have an inequality that has a variable in the denominator, I can't just multiply or divide or send that part of the inequality to the other side of the expression, because I don't know if this part here is positive or negative. I don't have any way of knowing. So that would be an incorrect procedure. Now, how do we know that this is a nonlinear inequality? Because we've got x, which is the variable that we're talking about, is here in the denominator. Okay, so that automatically makes it a nonlinear inequality. Okay, so does somebody remember what was step 0 of the different steps that we were using for solving a nonlinear inequality? Step 0 is very important. Can somebody tell me what step 0 was? Anybody?
We had to put like with a 0 and in the left or right side.
Correct, Estrella, thank you very much. So step 0 is that we need to represent this expression as an expression where there is a 0 on either side of the expression, but really we're looking for a 0 on the right-hand side of the expression. That would be step 0, okay? So let's go through the solution to this problem. So the first thing we need to do is that we need to create a 0 on the, in this case, on the right-hand side, okay? Normal cough, not COVID. And so what we're going to be doing here is that, first off, again, what would be incorrect, it would be incorrect, is for us to say, I'm just going to multiply on each side by x plus 2 and send that to the other side. That would be incorrect. We can't do that, or it's incorrect to do that, because we don't know the sign of x plus 2. And so that is going to make for an incorrect procedure, because depending on the sign, if it would be required to flip the symbol. Okay, so what we're going to be doing here is that this expression, what I'm going to do is what we can do is we can add and subtract on each side, and that doesn't affect anything. So if you notice, the first step that I am doing here, this part here, this procedure that I'm marking here, okay, this is going to be step 0, okay? And by the way, something that's also going to be in all my videos is that I'm going to be writing with my mouse, okay? And that makes my normally, usually ugly writing even uglier. But I hope it's understandable. So I'm not going to critique anybody for their writing, because my writing isn't that hot. It's kind of funky. And so this would be step 0. So notice what we're doing. The first thing is that we are sending this part, we are sending it to the other side, okay? And we're doing that by adding and subtracting. So the 3 is going to, this is positive, is going to turn into negative. and the 6 divided by x plus 2 is going to turn to positive. We just send them to the other side, okay? Once we do that, we have to find a common denominator, which would be x plus 2, and we are going to join the fraction. X plus 2 is going to be the common denominator. X plus 2 multiplied by x minus 3 plus 6. We're joining this together. And then we are going to multiply these two. X times x is x squared, minus 3x plus 2x is the multiplication of each of the variables, and minus 3 times 2 is minus 6, okay? With these elements that we've got here, we notice that the two 6's are going to cancel themselves out, okay? And so we're going to have x squared minus 3x plus 2x. Minus 3x plus 2x is minus x, and we've got x squared minus 2x, okay? The important thing when we're solving nonlinear inequalities is that we want to end up with a bunch of factors, okay? So we're not done until we have a series of factors. So there's a common factor here, which is x, and so x multiplying x minus 1 divided by x plus 2. And this is less than or equal than 0, okay? And this would complete step 0, okay? So step 0 is to leave the expression or have the expression with a 0 on the other side, okay? Now, does somebody remember what was step, after we do step 0, what were the next steps that we needed to do? What was step 1? Yes, please, go ahead.
The factorization.
Perfect, thank you, Enya. Remember to briefly turn on your cameras when you're speaking, but thank you, Enya. Perfect. So the next step would be factorization. And so this would be the factorization part. So we've left it with regards to, and I'm actually going to, just to be clearer here, I'm going to erase this connection here. So this is step 0, which would be leaving it with regards to 0. And then so, whoops, there we go. All of the videos are going to be with bloopers and everything, so bear with me. So step 1 would be the factorization, which is what we've just done here, okay? We've left everything with regards to factors. So this would be step 1, okay? Now I'm doing this slowly and I'm identifying the steps. You might do these steps automatically, but I'm trying to indicate the steps because it's important for us to be methodic. Okay, so step 1 would be the factorization. Now everything's factored, or rather nothing can be even more factored than what we have here. Okay, perfect. Now what was step 2? Anybody remember, please?
The roots.
Perfect, thank you, Enya. Again, so now we have to find the roots. Now, Enya, taking the opportunity here that you participated, the roots, how do we define the roots, or what would the roots be in this case?
Well, we need to pass the number to the other side, which means that x would equal to 0, x would equal to 1, and there's x plus 2. That means it could be minus 2.
Correct. Thank you, Enya. And basically what we're doing, finding the roots, and this is important. Remember this. Remember this. It's important because, again, I ask theory in my exams. And we're also going to revisit this concept further on in Unit 2. The roots are the values that make the element or the factor. They're the values that make it 0. So what makes x 0? 0. What makes x minus 1, 0, 1, and what makes x plus 2, 0, minus 2. So these are the 3 roots that we have that Enya was talking about, and correct, this is step 2. okay? My writing is so beautiful, I can't even imagine. There we go. Step 2. Thank you.
Professor.
Yes, please, go ahead.
The roots are the values of what?
The roots are going to be the values that make the factors 0. So Estrella, look at the, here we go. Let's look at these. These are the 3 factors. This is one of them. So what makes x 0? 0.
Mm-hmm.
Then the other factor is x minus 1. What makes x minus 1 0? If I substitute the 1, or as Enya said, if we solve for x, then x is going to be equal to 1.
1.
And what makes x plus 2 0? If I solve for x, then it's going to be minus
2.
So the roots are going to be the values that make the factor 0. Okay? And that would be step 2 here. Okay?
Thank you.
Okay, cool. Now, can somebody tell me what was step 3?
Intervals.
The intervals. Thank you, Viviana. Remember to quickly turn on your camera when you're speaking or participating. Now, Viviana, taking the opportunity that you participated, how did we establish the intervals, or how did we do that? Which would be this part here. Could you refresh our memories there?
Yes.
Mm-hmm.
You have to I don't know how to say it. It's because it's already there.
I don't worry, and don't worry about how you're saying it. Just try to express what you're looking at. And remember, this might be on YouTube, so smile for the camera. Step 3. Let's see, Viviana. We've got, how many roots do we have?
3.
3. And the 3 roots are in order. So it's minus 2, 0, and 1. So how do we establish the intervals? Kind of what are you looking at there, and how were the intervals set up?
So the first one has to be minus infinitive, and then the smaller number.
Mm-hmm.
And then the number you just used with the other.
The next one. Mm-hmm.
Yes. And since there are 3 roots, you use the previous number you just used with the
next one.
Next number, and then the last number with infinitive.
Perfect. That's exactly, you just expressed what we were looking at there. Perfect. So you go from, you order the numbers from the smaller one to the greater one, then you go from minus infinity to the first to the second to the third, so on and so forth, and the last you go to infinity. That's the way you establish the intervals. Perfect. Okay, perfect. Thank you so much. Now, these are the first 3 steps. Okay. This is I don't know what's happening with the light in here in my house, or like they say in Spanish, in your house here. I usually set up here in this space, and I don't know why the light is hitting it this way. I think it's because these problems are so important that we are getting a divine illumination, or I'm getting a divine illumination that's helping us solve these problems, right? So just put a thumbs up if you think that's the case. Thank you. Some of you do. Thank you. Preach. Okay, perfect. Let's go. Let's go on. Let's move on. Yeah, it's weird. I don't know why the light is following me. I don't know if that's good or bad. I'm not going to walk towards it. Okay, so we're okay up to this point. We've got the 3 steps. Somebody remind us what was step 4. Anybody?
The table.
Thank you very much, Andrea. Perfect. We have to do the table. Perfect. And so now we have the table here. And basically, how do we do normal cough, not COVID? How do we do the table? This table here, this would be step 4. Basically, we are going to put the factors in the. We're going to put the factors into each of the columns. Okay. I'm sorry. The factors are going to be in each of the rows. Cough, not COVID. And we're going to put the 3 factors that we have, and then we're going to put the whole expression here. And that's basically how we build a table. And in the columns, we're going to put each of the intervals and each of the values that we have, also the roots. Okay, so that's how we set up the table. What was step 5? Anybody? Or I'm going to ask somebody to participate.
Results, no?
It was fill the chart.
Correct. It's start to analyze and start to fill up the table. Okay, and basically the only thing we're interested in is the signs. Okay, so step 5 is going to be to fill out the to do the table. Okay. Okay, and we have to fill this out. Okay. Now, how are we going to do that? We're going to fill out here the signs that we're looking at. Okay. So let's see, Luis. Luis, can you are you there? Yes, perfect, yeah, Luis. Hi, let's turn on your camera briefly. Let's go with the first row, and we're going to do this quickly. We're going to look at x. If we go in the interval from -infinity to -2, what sign are we going to have with regards to x?
Minus.
Negative. Correct. Thank you very much, Luis. If we look at -2, what sign are we going to have?
Negative.
Correct. Perfect. If we go from -2 to 0, what sign are we going to have?
Depending on well, minus or, yeah, right.
Negative, right? If we take any number.
Negative or 0.
Well, no, not 0. This is a good observation because this is an open interval.
Oh, okay.
Okay, so we're not looking at the values on the that's a good observation. We're not looking at the values in the edges. We're just looking what's in the middle. But now if we go to 0, what are we going to get?
0.
Correct. And if we go from 0 to 1, what are we going to get?
Positive.
Any value there is going to be positive. If we go to 1, what are we going to get?
Positive.
And we take any value from 1 to infinite, what are we going to get?
Positive.
Perfect. Thank you so much, Luis. Perfect, perfect. Now let's go to the second row. And let's see Juan Imperial. Juan, are you there? Juan, or else we're going to have the whole group.
I'm here.
Yes,
I'm here.
Perfect. Perfect. Thank you, Juan. You are in constant movement. You are always somewhere. That's good.
Yes.
That's
sorry
good.
about that. Is there a problem with that?
No, that's not a problem. But let's just. The only thing I want is for all of you to be in whatever place you're going to be, but paying attention. Okay.
Yeah, I'm always paying attention.
That's the important thing. So let's see what we're doing here. So if we take any number from -infinite to -2, what's going to be the sign from for x minus 1?
Negative.
Yeah, and let's verify that. So choose any number from -infinite to -2.
-2.
Nope. Between -infinite and -2.
-1.
Nope. That's also not between -infinite and -2.
Oh, -2. I'm sorry. -3. Sorry.
-3, correct. So if we substitute -3 here, what are we going to get? -3 minus 1 is?
-4.
-4. So correct. This is going to be negative.
Negative.
Normal cough, not COVID. So if we grab the -2, what sign are we going to get here? Now we are taking the -2.
Negative.
Correct. Perfect. Now we go from -2 to 0. If we grab any number here between -2 and 0, what are we going to get?
Negative.
We're still going to
Negative.
get negative. Correct. If we take the value of 0, what are we going to get?
Still negative.
Still negative. Correct. If we take a value between 0 and 1,
You can get 0. And
so let's think of a value between 0 and 1. Give me a value between 0 and 1. Any value.
0.5
0.5, correct. So 0.5 minus 1, we're going to get?
minus.
Minus 0.5, correct. It's going to be still going to be negative. If we take the 1, what are we going to have with the 1?
0.
0, perfect. Thank you very much. And lastly, if we take any value from 1 to infinite?
Positive.
Positive, perfect. Thank you so much, Juan.
Thank you.
Perfect. Now let's go with, let's see. Javier. Okay, Javier, let's, perfect. Let's go to the next row. So we've got x plus 2. If we go from minus infinite to -2, any value here, what sign are we going to have here in x plus 2?
Negative.
Negative, perfect. Because if we take any value, for example, give me a value between minus infinite and -2, any value.
-3.
-3. -3 plus 2 is -1, so it's negative. If we take the value of -2 and substitute it here, what are we going to get?
0.
0, perfect. If we take any value from -2 to 0?
Negative.
Let's see. Give me a value between -2 and 0.
Positive. It's positive.
Let's grab one value. Give me any value.
-1.
-1. -1 plus 2 is +1. So we're going to have a positive here. Okay. If we take the value of 0, what are we going to have?
Positive.
Positive. Perfect. Normal cough. Still hoping it's not COVID. Okay, let's go from 0 to 1. Any value from 0 to 1?
1. It's positive.
It's going to be positive. 1 isn't a value between 0 and 1. A value would be 0.5, for example. But any value plus 2 is still going to be positive, correct? If we take the value of 1, what are we going to have?
Positive.
Positive, correct. And if we grab anything from 1 to infinite, what are we going to have?
Positive.
Perfect. Thank you so much, Javier. So if you're noticing something here, we've got the roots here. So for the factor that generates the root, usually we're going to have a sign, then a 0, then a change of sign. Notice that that's happening in most of these cases, okay? So good. And let me just verify here. I think we've got a question here in the chat. I just want to check it. It's not letting me show the chat here, but okay. We're going to continue, okay? Okay, COVID alert, yeah. Hoping it's not. Okay, so let's go now to the complete factor over here. And now we're going to add, in the exercise that we did before, we only had 2 things that we were comparing. Now we're going to be comparing 3 things, okay? But the sign, the sign changes still apply, okay? So let's look at the whole factor. So x is multiplying x minus 1, and it's divided by x plus 2. So we still have to, the signs still have to apply. So minus multiplied by minus divided by minus is going to give us what values? Let's see somebody here. Whoops. Let's see. Alejandra. So please turn on your camera quickly. Hi, Alejandra. So let's help me out here. So what is going to be the sign of the complete factor in this case? So it's minus multiplied by minus divided by minus. What are we going to have here?
Negative?
Correct, because it's minus times minus is positive. Divided by minus is negative. Correct. The second column, minus multiplied by minus multiplied by 0 or divided by 0. What are we going to have there? This one's a tricky one. Well, let's look at this. Minus multiplied by minus is positive, right?
Yeah.
But what happens when I divide by 0? Is that valid? Is that a real?
value.
It's not a real.
Correct. It's not a real number. Okay. So whenever we divide by 0, what we're going to write down here is, we can write down any things. What I'm going to write down is NaN, or not a number. Okay. So it's not valid. Okay. Thank you. Now, next one. Minus times minus divided by plus. What are we going to have here?
Positive.
Perfect. 0 multiplied by minus divided by plus. What are we going to have here?
0.
0. Correct. Big old 0 there. Plus multiplied by minus divided by plus.
Negative.
Negative. And plus multiplied by 0 divided by plus.
0.
0. And you tell me what the last one is.
It's positive.
Positive, because positive, positive, positive is positive. Thank you very much. Perfect. Now let's stay with you. We're going to go here to the last part of the steps. Okay. And in the last part, we have to go back to the expression here and look at the symbol that we have here, which is less than or equal than 0. That means it's negative or 0. Okay. And let's look at each of the intervals. So you tell me, in the first case, is this interval part of the solution? Yes or no?
Yes.
Because it's negative. Correct. Thank you. Perfect. Is the -2 part of the solution?
No.
No, because it's not a number. So no, this is correct. This is not a part of the solution. Is the next interval, -2 to 0, is that part of the solution?
No.
Because it's positive. Correct. We're looking at things that are negative or 0. Is the 0 part of the solution?
Yes.
Yes, because it's less than or equal than 0. Okay, so this is part of the solution. Okay, the next one, it is negative. Is the next interval part of the solution?
Yes.
Correct, thank you. Then we've got the 1. Is the 1 part of the solution?
Yes.
Correct. And lastly, the interval from 1 to infinite, is that part of the solution?
No.
Correct, because it is positive. Perfect. So now we've identified, and that's the last step, we've identified the intervals that are part of the solution. Thank you very much. Perfect. You did great. Okay. Okay. So now that we have this identified, thank you very much, Alejandra. The next part is now this is just exactly the same table that we've got in the previous slide, just that it's the complete. It's me bringing out the cake that's already baked. Okay, and here we've got all of the steps. Okay, and so we've identified, and lastly, we identify the ranges. And we do that here in the number line, okay? And so remember that there's many ways to represent it. This is a representation in the number line, but if we go back here, let's do all of the representations. The first interval is from -infinite to -2. So the solution is from -infinite to -2. And notice that this is an open interval. Why? Because the -2 is not included, okay? And so this is an open interval. And the infinite is always going to be open, okay? The next interval is from 0 to 1. And notice that the 0 is included and the 1 is included. So this means that this would be joined with the closed interval from 0 to 1.
Teacher, I have a question.
Yes, please go ahead.
When we use bracket, we have to put the union, the U.
No, the union, that's a good question. Let's see, it was Viviana, right?
Yes.
Okay, that's a very good question. No, the union is because of the following. So Viviana, you tell me how many intervals are included in the solution? Two, correct. The intervals that are included in the solution, and I'm just gonna mark them here. The intervals that are included in the solution is this one here, not including the -2, and it's this one here that does include the 0 and the 1. So there's two intervals, okay? So the solution includes all numbers that are in those intervals. So the way we express it, and this is why there's a union here, is that the solution are any numbers that are here, but also are here. So the union is that you're joining both of the intervals or the solutions. That's what the union means, okay? And so if we had 3 intervals or 4 intervals, we would keep joining them by U's. That just means that we're joining them, okay? It's joining them because it's this one or this one. A number can't be part of both of them. It's either one or the other. So that's why we use the U. So always when we have many intervals, we're going to join them in the solution this way, okay? And so this would be the final solution to the problem, okay? And we're representing it in the number line, and we're also representing it as an interval, okay? So questions before we move along. Okay. No? Okay. If there aren't any other questions, I am going to pause the video right now, and this is going to be the second video in the Solving Stuff with Sosa series. And I'm going to put this available for you guys, and I'm also going to put this up in YouTube so you can see it. Okay. I'm going to stop recording now.